Also, I would like to remind you to record.
Okay, I just turned it on, so we're good. Thanks. Um, so I'm going to share my browser window, and we're just going to go through the assignment real quick. I can remember how to do that. Okay, so I don't think this will be one of the harder assignments. Basically, I think it's mostly just sort of putting the pieces together. So basically, we're going to complete and test the hashed dictionary class that was started in the text. So it's broken down into steps here. The first step is going to be to complete the entry class. So the text provides the header file. You're going to write the implementation file. And it's just constructors, mutators, and accessors. So I've got it down here for you. Here's the header file that's given in the text. So you'll just be providing the implementation. And this just represents an entry in a dictionary. So an entry in a dictionary has a search key and it has an item. And then once you've got the entry class done, then you're going to complete the hashed entry class. So the hashed entry class, again, the text provides the header file. You're going to write the implementation, and it's just constructors, accessors, and mutators. Basically, the hashed entry class is inherited from the entry class. And so it gets that search key, and I don't remember the data member was called item, I think. Let me just check that. Right, item and search key. So basically the hashed entry class is going to get the item and the search key from the entry class, and then it's also going to have an additional data member named next pointer. So that's going to be a pointer to the next entry in a linked list of entries. So what we're doing here is the hash table where each element of the array is a linked list. Hopefully, normally you'll just have one or two items in each linked list. So they won't be long linked lists unless something goes really wrong. Any questions so far? So I'm kind of assuming that you were here last time, or you've taken a look at the book, but I guess we could give me just a minute. It might be helpful to just look at one of the diagrams from the textbook, if I can find it. Okay. Let me switch my share for a second here. Or actually, I guess I'll just show my text. So if you see the diagram over here on the right, this is what our hash table is going to look like. So you can see that a hashed entry is going to look like this, and where the entry this part over here would be just a regular entry, or just consist of the data members that come from the entry class. And then adding on to that is the next pointer that points to the next node in the linked list. Okay? I don't know if the picture helped anyone or not, but worth the try. Any questions so far?
Nope.
All right. So then we've got our hashed dictionary class. You're a little bit more on your own there. What is provided for you, though, are the two major member functions. So here's the add member function, adding something to a hash table. And here is the remove function given to you. Okay, so your job is going to be completing the task of putting the header file together and then providing the other member functions, which for the most part are less involved than those two were. And just note here that the text provides, the data members are given to you in the text. Okay, so you make sure you go back and look in the text and see what the data members are going to be when you go to put that header file together. So for the part of the job of writing the hashed dictionary class is going to be writing the actual hash function itself. But let's come back to that in a minute. I'm just sorry, I'm pausing here because I intend to require you to use Horner's rule, but I don't. It doesn't look like I actually make that clear here anywhere. Maybe it's clear from the text, but anyway, I'll think about that later. Okay, and then so step 4 is to write a client program to test your class. I have provided quite a bit there. We're going to be writing a client program that is going to be processing something I call famous people. So I'm providing a text file that looks like this with just a list of entries into the hash table. This is like an ID number. This is a tax status, married, single, or head of household. Last name, first name, age, street number, or street, I guess, and zip code. Those are listed here. And then I also am providing a sort of starter client file. So here's the struct that is going to hold a single famous person. And then I've got a main that basically just reads the file in and then displays the entire hash table. So you'll be adding quite a bit more to this main function here so that it tests all the other member functions of the hashed dictionary class. How does that sound? Anything else? Any questions come to mind? I'm still gonna, oh, look at that, there's 5 chats. Is entry going to be an abstract class? No, entry will be a regular old-fashioned class. You could declare variables to be of type entry, it's going to have, and for one thing, an abstract class doesn't have data members. The entry class is going to have two data members, the item and the key, the search key. I see that I'm probably like 5 minutes little party. Okay, sounds like we got that worked out. Anything else you want to talk about besides I'm going to actually go and talk about what the hash function itself is going to look like.
That's what I'm interested in.
Okay. Excuse me. Not too bad. We're going to be using Horner's rule. If I can find it. Oops. This could probably just. And then try to find it. Jeez. Not even finding it that way. All right, give me a sec here. I haven't even gotten to patch on.
Here, ladies and gentlemen, you can see how inefficient linear search is.
566. No. I think basically we're doing programming exercise 9, and that's why. Okay, here we go. Oh, no, it's Zoom. It's over here. Okay. Oh, maybe because I'm searching. Nope, still not Zoom. All right, I guess we're not zooming. So here's what we're going to do. And this is sort of the way that he introduces this is a little weird to me. So it's in this section called converting a character string to an integer. And that's basically what we're going to be doing. Because the search key in our situation is going to be the last name. But he goes into this whole thing about converting it into binary, and I don't think that you really need to go through that step. Basically, all you need to do is say, okay, let's say, for example, the string is note. What we're going to do is we're going to use what letter of the alphabet the character is. So N is the 14th character of the alphabet, O is the 15th character of the alphabet, and so on. And we're going to multiply that by a power of 32. So N is going to be 14 times 32 cubed. O is going to be 15 times 32 squared, and so on. If you're familiar with converting between bases, which you should be at this point, but if not now, then I'm pretty sure you'll do that on Math 4. But if you're not, then this may not help at all. But basically what's happening here is this is basically the same process as if you were treating the word note as if it was a base 32 number, and then you're converting it into decimal, right? So anyway, the rightmost character in the string is going to be multiplied by 32 to the 0. The next digit to the left, or the next character to the left after that, is going to be multiplied by 32 to the 1. The next character to the left after that is going to be multiplied by 32 squared, and so on. Okay? Just as a matter of trivia, I'm not worried about going into too much detail with this, but if you read about this online or in other textbooks, you're probably going to see a prime number here used. The argument being that helps to ensure that the hash codes, the result of the hash function, are going to be more randomly dispersed. So you'll see things like 37 or 31 here. Basically, you could use 26, right? As long as you use a number in the place of the 32, as long as you use a number 26 or greater, you're going to be guaranteed to get a different result for every string. So does it make sense what we're doing here? So do I need to keep going about that? Or let's put it this way. If there aren't any requests for me to say more about that, I'm going to move on to how we're going to actually calculate that. So a couple problems with this. One is these operations can be fairly time consuming, and you don't want to have a hash function that's consuming a lot of time. I mean, if you're using a hash table in the first place, it probably means that time is of the essence. And the other issue is that it's not unlikely that you're going to get some numbers going here that are going to be too big they're going to overflow a variable, okay? So we're going to have some strategies to reduce the number of operations and also make sure that we don't overflow. Those strategies are, number one, and this is Horner's rule, we're going to factor this expression, okay? So, and this is what we end up with when we factor that expression. I don't think I'm going to take the time to actually show you how this and this are equal. Hopefully you can sit down with a pen and paper and work that out if it's not immediately clear.
Makes sense to me.
Okay, so this is the calculation you're going to do. So you can imagine that you're going to have some sort of a loop that's going to go through each character, figure out which character of the alphabet it is, multiply it by 32, add the next character, multiply that total by 32, add the number for the next character, multiply that by 32, and so on. Okay? So hopefully you're looking at that and it's fairly, I mean, the details may not be there, but there should be at least a vague idea of, okay, that makes sense. There's going to be a loop going through each character, multiplying it by 32, adding the next character. And then the only other thing that we're going to do is this still is fairly likely to cause an overflow. So what we're going to do is each time we finish one of these expressions that's in parentheses, we're going to do a modulus by the table size. Okay, so if the table size is 1,000, then if the table size is 1,000, then we're going to do 14 times 32, add 15, modulus 1,000 before we multiply by 32 again. Then add 20, then modulus 1,000 before we multiply by 32 again.
In this particular case, because they're powers of 2, we could also use the bit shift operator, right?
That is true, you could. You mean instead of doing the modulus or instead of doing the multiplication?
Yeah.
Yes, that's true.
Do you mind if we do that in the assignment, or
that's fine?
Do you want us to just? Okay.
Nope, that sounds fine. Basically the reason for doing that would be that that would be a lot more efficient than actually having to do the multiplication. All right, so that's the hash function that we're going to be using. Any questions about that? Okay. That's all I have for today. Anything else that you want to talk about? All right. Well, in that case, hope everyone has a happy Thanksgiving. And I will plan on seeing you next Tuesday.
Happy Thanksgiving.
Happy
Thank you, Dave.
Thanksgiving, everybody. Thanks.